The main technical aim of the project was to develop the most track-focused, engaging expression of the Super Series McLaren vehicle. There are three significant innovations on the 675 LT compared with the 650S. We've obviously developed more power from the engine, 675 PS now, and with that associated is the new exhaust system. For the first time we're seeing a lightweight crossover exhaust system, and we have evolved a unique brand sound for the LT variant. The second is the gear shift strategy. We've worked very hard on the gear shift. The 650S is extremely refined and fast as a gear shift. The 675 is intended to be more brutal, more engaging, and we have introduced two things: a cylinder cut. So in sport mode there is a disruption in the fueling to the cylinder, which results in a very fast, snappy and audible gear shift. In track mode we've actually got a inertia push, which means that we're using the inertia of the engine to make the gear shift even faster. The third innovation is the race data display. We've introduced as an app on the center console a feature which builds a lap, allows you to compare lap times with previous laps and sector times over previous laps, and the data can be downloaded. The 650S, as we know, is an extremely accomplished all-round car. It's happy on a racetrack and happy on the road, and the priorities for that car are very much addressing all of those environments. The 675 LT is a more track-focused car. That doesn't mean to say we've sacrificed overly refinement, but we have knowingly compromised refinement in order to improve the engagement and the driving experience, and specifically to improve the performance at high speed on a track. So the car feels very connected to the driver. The steering is a little bit sharper, the handling is a little bit firmer, and the gear shift, as I mentioned, is much faster. The noise is increased inside the car, it's more engaging, it's a more feral car. The performance of this car sits between a 650S and P1. The 650S, as we know, is the fastest accelerating car in its class. The 675 is over 100 kilos lighter, has 25 more PS, and so the acceleration is significantly improved over 650S. P1, as we know, is extraordinary with the addition of the electric motor, so the initial throttle response is much greater, but that's in a different class. The aerodynamics of this car have been developed for downforce to increase cornering power on the circuit, for stability, and to improve the cooling. With the extra power we need more cooling capacity. To achieve this, we've lowered the front of the car relative to the rear, which has given us an ideal aerodynamic balance and enabled us to achieve overall increased levels of downforce. We've got a much larger splitter at the front, and we've introduced this wing end plate feature, which is a device which assists front downforce but also cooling, which I'll come on to. With the extra power comes the need for extra cooling. The wing end plate on the front splitter helps to steer air past the turbulent air from the wheel and guide that air into the side air intakes. Because of the extra power, we need extra airflow coming into the air intake. So we've got a much larger main air intake, and we've introduced an additional lower air intake to maximize the cooling performance. In addition, we've actually moved the radiator position inside. The design of the rear of the car is fundamentally driven by the functional requirements. The exhaust pitch is a function of the NVH characteristics, that's the noise quality we wanted from the exhaust. The increased exit area above and below the bumper is required because of the extra power from the engine. And the much larger rear air brake is part of the active aero system. It has 3 positions. This is the low position, it has a driver downforce position, and when acting in full air brake mode comes up even higher. And this is what allows us to achieve a balanced 40% increase over the 650S in terms of downforce. We can also see at the back more evacuation for heat on the top of the car. So the new engine cover glazing is polycarbonate, which saves a huge amount of weight. This is a composite frame underneath, and we've got slots cut in there for heat evacuation, a new hot air exit above the exhausts in front of the rear air brake. Most of the weight saving of the car comes from the rear rather than the front. This was deliberate to improve further the balance of the car in terms of its weight distribution for ultimate track performance. So as well as the lightweight polycarbonate engine cover, the panel here is carbon fibre, the air brake is carbon fibre, the bumper is carbon fibre, the rear fenders are carbon fibre, and the rear side panels are also carbon fibre, as light as we could possibly get them.